Hello everyone, my name is Rajesh Roy. Today I am going to share one of my projects that I made recently. It is about RAG model and generative AI. I have used Google Gemini as the large language model and used Llamma-Index for implementing the RAG model. I have heard that Llamma-Index is pretty great for making indexes and querying from it. Not actually for querying. There are some difficulties that I have faced for the prompting techniques, but it is great for indexing and it has very efficient way of making indexes and retrieving it. That's why I have used um, Llamma-Index, and for a vector DB I have used Pinecone. Then for frontend I have used Streamlit. I would show all this. Here is my main.yaml. I have used GitHub Actions for CI/CD pipelines, and again here is my secret keys. I am because I am using Pinecone API and Gemini API key. I am passing this as a build arc here, and in Docker file I am using them as this from arc to environment, because arguments won't be available in the Docker image itself. That's why I am using argument here, and then the environment would take like this. Okay, then let's come to my research folder. Here is the trials. This is my initial experiment. So I am using this so that this Jupyter notebook can access this data. Here is loading the env API keys. Here is the normal imports. Here is taking the API keys. Here is taking the data. In total, um, these two PDFs make a total of 34 pages. Here is the first document page. I am using regex to clean the data in the text. I have actually referred this from Pinecone blog because drag model is pretty new. That's why I have used a lot of blogs and articles for it, because I can find the proper tutorial in YouTube. That's why blogs and um, official documents were pretty good. Here is the clean document. As you can see, it is pretty much cleaned from before. Here we can see a lot of slash, and but it is pretty good to read here. Then it also makes the metadata, as we are using simple directory reader. Then Chain AI configured. It's very important. If we don't keep it, then we can't access the Gemini model or Gemini embedding. So here I am using this model embedding and Gemini Pro. Here is the API key. Temperature is 0.3, so that it would stick to the documents itself and won't give risky responses. Here is the pipeline. I have taken this from the Pinecone documents itself, Pinecone docs. Here is the settings. This is the new thing. Before this, we used to use service context. Here is the settings. We are integrating model and Gemini embedded model itself. Then sentence splitter. Here is the Pinecone vector store. I have created the AI assistant index in Pinecone itself, and then I am using this to retrieve those and connect to that index. Here is the vector store as we are using it. So here is the pipeline, and by running this pipeline, finally the cleaned docs would be upserted to that Pinecone database. I have used this. Here is the output is not showing. After we would implement and upsert those documents to Pinecone database, then we can also see the describe index tags. Here we can see that our total vector count is 85 and my dimension is 768. Then I am using Llamma-Index itself to query it. Here is the vector index retriever. This vector store index would retrieve that vector store here is the vector store index. It is using this index, and from this vector index retriever would retrieve this. Similarity top here we have taken 5 so that it would fetch top 5 similar vectors. Then here is the answer for this, generate a summary based on this. So correct answer. PEFT has the rank classification method, and then REFT model would have this. REFT is basically the reinforcement parameters. Okay, reasoning with reinforced fine tuning. Okay, then continuing with this, I am using query engine. Similarity cutoff I have taken 0.7. Here, post processor would go here. I would say that I am facing some problem here, as the query engine for Llama-Index isn't that great. I'm here using the prompt template. Here it would act as a QA assistant and help in research work as a research assistant. Then old QA prompt, here the old QA prompt would go here, and query engine. After that we would get rank classification as this, because PEFT is pretty bigger and I have stored it in the vector database a lot of times. That's why it is giving this. Then if we use this pp prompt sorry, we would get this, and it would show us that which that from where we have taken this rank classification response is coming from these two texts. We can see the similarity for 0.49, 0.51. So here it is. I am still figuring out how I can improve this prompt engineering, and how I can get better results and better similarity scores. I mean, maybe if I change the chunk size, change the chunk overlap, then I may get a better result. I am still working on that, but to show what I can do with this, some of the things like T-Few recipe. If you see here, print find T-Few. Here is T-Few recipe. There are a lot of times we have seen T-Few recipe, but for some reason it can't configure that. Okay, if we change it to where is the T-Few? Tell me about T-Few recipe. We can provide the context. It's taking some other ML intern. I have used this before to store in VectorDB, but still, although these are implemented in the VectorDB, it can query from this. I will still figure it out, but moving on to the main components, here is data indexing. As you can see, I have implemented these LLM models in the settings. Then here is the pipeline. Here I am calling the pinecone. Okay, before that, data ingestion will come. Here I have implemented the regex model. Here is the cleanup text. Here is the cleaned directory docs. This would this function would clean all the docs from this data folder, and this get clean input docs would only clean the docs of the input file, which I would take from Streamlit. I have used this for just showing that if it's working or not. Then here is the data indexing. Here I am using pinecone. This pipeline would trigger. The trigger is the pipeline.run. By this run indexing pipeline, here is the Gemini configuration, and then pipeline would run, and I would return the describe index that okay, it's actually running. We don't need actually this return. We don't have any use of this written statement pinecone index dot describe index stats. I am just using this to show that okay, actually it is running and we are getting some result because our main indices would get upserted to pinecone database. We don't have to do anything with it. Then coming to data querying, here is a pinecone PC. This vector index retriever will retrieve from this pinecone vector store. Here is the pinecone vector store. This is function. I have used implemented it as a function. So all you can see, I've implemented this from the trials.ipynb. Here is the proper prompting. Here is the context string. And this user query is the main thing that we would implement in the app.py. So Gemini configuration here also, my query index, vector index, here is the vector store. Vector store is coming from right here. I am not using it as a function. So here is the query engine after proper prompting. Then we would get the question and implemented it as a query from the query engine. Then we would get response. Then we would return the response of the response because this response also have a lot of sub elements. We won't need all the sub elements. We just need the response to the response. So after that, well, here is the logger itself. It is the logger of research assistant app. Here is the packaging. Or then coming to app.py. App.py is the main file, which is powered by Streamlit. So I'm calling the get clean input docs user query run index pipeline. So what happens here? I'm calling the Google API key. Here is the Google API key. I'm configuring it. Then here is the chat PDF. Okay, here it is. Powered by Gemini. I am trying to make it as a research assistant. Here, though we already have the vector database from Pinecone database, which and our app would retrieve retrieve vectors from that Pinecone database, and we would configure it here. And if we want to update our database by uploading our new PDFs, we can do this from here. Upload your new PDF file to store in Pinecone database. Okay. So continuing, if we have the file, then we would store it in the data, and from there we would save it. If we have this file, then we would say that okay, so our file is successfully saved. Then what we would do, get clean input docs. As I said, that this would only create indexes and clean the data from this particular PDF only, not the whole data folder. So from here we would take the clean docs. This is the result, and then we would get index stats. This is only to show that okay, our indexes indexes are properly upserted to the Pinecone database. Okay. Here I'm showing that if index stats is not none, means that we are actually getting index stats and our code is properly running, then we would get file successfully upserted in Pinecone database. Okay. So then we would see that ask the question from the PDF file. Actually, if I didn't use this, then also it would be okay, because if I upsert my PDF from here, then at the end of the day, all the PDF vectors are going into the Pinecone database, and I can just query it from here. But to just show, I am using here. Then it would show response here, and file would be none, so that it don't get triggered again. So it is all here. Then Docker file I just showed. Here is the requirements. Okay, now let's see my actions, GitHub actions. Where is it? Those are circles here. Okay, here is the continuous integration, all running properly. Continuous delivery. There is the building, installing the requirements here, and properly building the Docker image. Here, continuous deployment is deployed properly. Everything is running smoothly. Here you can see this Docker PS. This is my app, Streamlit Run API, app.py. AI Research Assistant is its name. So here you can see, and for Docker logs, AI Research. Okay, I have implemented it before. You can see there is a lot of things. So here is the upserted vectors. This is because it is upserted properly, and this is cleaned docs. These clean docs are coming for this, and that upserted is coming from this. Okay, so here is my Streamlit. If I take it, okay, although this is already upserted, I am again upserting it so that you can see that it is properly uploading the file. So I would browse it to get my ref paper. It is uploading properly. File paper, ref paper is successfully saved. It is running. Okay, let's wait a few minutes. Then so totally I have used Llama-Index, Google Gemini, uh, Pinecone vector database, Streamlit, GitHub Actions, and AWS EC2 and ECR. Okay, it's taking quite a while. Okay, if I just show you in the locally, Streamlit app.py. Okay, it's taking quite a while to upsert it. Maybe internet issues. It is taking time here also. Okay, let's just. Hmm. Okay, it is successfully. Okay, now we can see that our reft paper.pdf is successfully upserted to Pinecone DB. So let's see what we can query from it. Okay, let's see. One way to enhance the reasoning capability of large language model is to conduct supervised fine tuning. Let's see if can answer this. Hmm. Tell me a way to enhance the reasoning capability of large language models. Let's see what can give. Okay. Chain of thoughts is a technique that can be used to enhance the reasoning capability of large language models. This technique involves providing LLMs with a series of prompts that guide it through the reasoning process step by step. By doing so, the LLM is able to generate more accurate and detailed response. So we can see it can give quite decent response. Here is the chain of thoughts is mentioned. Okay, let's refresh it and see what it can give. Let's see. Tell me everything about your provided context. I am using this to see that what it can give for the provided context, which is saved in the vector DB of Pinecone. So let's see what it can give. What it can give. Okay, this ML paper was already saved in vector database, but I have deleted it from the data folder. That's why you can see it here. Okay, this is showing the ML interview video, ML interview questions, and here is the training parameters of reinforcement learning. This indicates to that drift paper. Maybe the paper is not in the data database. Okay, that was all for today's project. I would try to improve this project by implementing some more prompt engineering techniques or maybe integrating LangChain in the query index. I've tried it, but I was failing to get proper documentation of that. So I would keep looking for it and ask my peers that what they suggest for it. I have also tried to use Circle CI, but unfortunately, I can't understand the proper docs about how to implement it to the ECR, then deploy to EC2. I would keep looking for the documents and understand more about Circle CI so I can implement that to the next project. So this project shows the efficiency of Llama-Index and Google Gemini. I would keep making new projects about generative AI. I am looking forward to specialize in generative AI, seeing its boom and how many openings are there in the future. But I would keep adapting and learning new things, whatever happens in the future. Thank you. That's all I had to say about this project. Thank you for sticking up for this part.